You want to find the antiderivative of sine of ln x dx. So using the integration by parts, u is equal to sine ln x, okay, du is going to be equal to, using the chain rule, first you will have the cosine, right? Cosine of ln x, and then multiplying this by the derivative of the inside. Derivative of ln x is 1 over x, right? So we can just divide this by x. Okay, and don't forget the dx. Now dv is going to be equal to 1 dx, right? Because everything else is just 1. And v is equal to x, right? So that is equal to uv, the product, x sine ln x, minus v du. Now v du, the product, the x's will cancel out, right? So you will have basically minus integral of cosine of ln x dx, and that's it, right? Because the x's would cancel out if you multiply the v and du. Okay? So using the integration by parts substitution one more time, and there's also a constant, right? Because we integrated this part. That's the antiderivative, right? So there's a constant there. Okay, so now using the u and dv one more time, u is going to be equal to cosine of ln x, right? du now is going to be tricky because now you're going to have negative sign, right? Negative sign of ln x, and also the derivative of the inside is multiplied, which is again 1 over x, so we just divide this by x. Okay, and the dv one more time, and don't forget the dx, right? dv is going to be 1 times dx, right? This part here, that's the dv, and the v is equal to x, right? So we will have, I'm going to copy this down, x sine of ln x minus the product of the uv, right? So we bracket that. So x times cosine of ln x. Okay, minus v du. So minus with this minus is plus, right? The integral. Now again, the x's would cancel out, so it's just sine of ln x dx plus a constant, right? That's going to be another constant, so we can just put it as a capital C like that, because the constant would change. It would add, this constant would add to another constant, so we would get, but you don't need to worry about that. Even if you don't write that, it's not going to be wrong, unless you forget to write the constant in the very last result, when you finally find this antiderivative, right? Okay, so if you distribute the signs, first let's set this on the left side to the integral whose antiderivative we're trying to find, right? So it's going to be x sine ln x minus x cosine of ln x, right? Minus, distribute this minus the integral of sine ln x dx, right? And then plus a capital C. Now notice something interesting. Notice something interesting. This you can treat as a variable, right? Because you see that you have two identical integrals. So that means you can treat them as a variable. You're going to add this integral on both sides, basically. You're going to add it and treat it like a variable, right? So in the end, you will have two integral sine of ln x dx is equal to x sine of ln x minus x cosine of ln x plus big C, the big constant. So if you divide both sides by 2, you will have solved for the original integral, right? So that's going to be, dividing both sides by 2, you solve for the integral of interest, which is equal to, so x and 1/2 can be factored out for both of these terms, right? So 1/2 x can be factored out, and then we bracket sine of ln x minus cosine of ln x, bracket closed, and then the capital C can be changed to small c, right? Because it would multiply 1/2, right? So as usual, it could be the small c. So that's your final answer. This is your antiderivative. Thank you so much for watching. Hope this was helpful and enjoyable, and see you in the next video.